Hello everyone, thank you very much for joining today's webinar. This one today is based around AI and automation in Fusion. This is something we get asked a lot about, especially recently with the introduction of things like ChatGPT and the other AI software in the world now. A lot of people have been asking us, hey, when is this technology going to start finding its way into these CAD CAM solutions? And we've got this question so much, we decided to run a webinar on it to show you basically what's available inside Fusion as of today, but also give you a glimpse as to what's coming in the future, because this world is very exciting and it's really going to be a lot of what we're talking about in the coming years as well. So today's webinar is presented by myself and my colleague Vipul. I am a technical specialist based in the Australia and New Zealand region. Vipul is my equivalent, but based out of the India region as well. So a lot of us, a lot of our customers have probably spoken to us previously, so it's great to see some familiar faces in the webinar today as well. As a way for a quick agenda, before agenda, let's do a quick safe harbor statement because we will be talking about some future and forward-looking possibilities within Fusion. We'll be making forward-looking statements. Just a disclaimer, base all of your purchasing decisions on what is available as of today, because even though we have ideas of what's coming in the future, maybe in a timeline, we can't always guarantee it, and things of course always do change. So just make sure if you make any purchasing decisions, it's based on what's available as of today. With that, let's look at our agenda. We've split it into 8 categories, 4 in design, 4 in the world of make. I'm going to be covering the design capabilities. These will be going through what's called automated modeling, generative design, automated drawings, and then finally API automation. All 4 of these are very exciting areas that we love to talk about and showcase to a lot of our customers. Vipul will take the make side halfway through the webinar. So with that, let's go straight into it. The first thing that I want to point out that we have as an AI and automation tool is what's called automated modeling. Now, this is available as of today to all base license users. Effectively, it's I guess an automated concepting tool is probably the best description for it. What you do is what I'm doing here. I've got this structure I want to design a bracket for, or get an idea for a bracket, and I simply defined the areas I want to connect, the areas I want to avoid, and then I just go ahead and hit generate, and the thinking machine within Fusion is going to come up with some designs for me. Now it's going to present 6 designs. 3 will have what's called sort of soft connections to the brackets, to the parts I want it to connect, and the other 3 will have sort of hard connections, sort of more straighter edges. So you can have sort of an organic connection, or you can have more of a, I guess, a machine finish connection. Okay, but it will then give you some, within that, different alternatives as to actually how to produce the bracket itself, and it will come up with a structure like this fairly quickly as well. The idea is not by any means to be a finished part, but more to give you inspiration, more to quickly just give you some ideas of what a potential bracket could look like, and you can create a series of these just to help guide your thoughts. You can actually use it, and I'll show you that next, but ultimately this is what this is for. It's just a quick, rapid concepting tool to help your thinking, help accelerate your thinking, and help you get started with your design process. So leveling up from automated modeling, we go into something that's called generative design. Now this has actually been inside Fusion for quite a number of years now. We've got plenty of users around the world using it, and they're absolutely loving the results that it can produce. This is probably the closest we've got to full AI design. It often gets called the AI designer. So we'll showcase what this can actually do because it is quite fantastic. 3 stages here. I'm going to start by just showing what the model is, what we're going to try and generate out of generative design. This is a real world part. This was taken from a real world example. This is a camera gimbal. So the idea is you got a camera and it attaches to a bracket at the top, either on a boom or a flying drone perhaps. And we've got to connect these 3 green areas together. We've got the top mount, and then we've got left hand and a right hand mount on the camera themselves. And we just need to create a bracket that connects these 3. Now we could of course do this on our own, but it's never going to be as efficient if we let a generative design do it for us. So that's why we chose to give it the generative design treatment. So how do we go about setting this up? So just a quick word on how to set this up and show you the sort of thought process you go through. Firstly, you define the areas that you cannot build into. I've labeled them red. These are what we call the obstacles. In addition to that, you then define the areas that you want to keep. Now you have to have some preserved because these are the areas that generative design is going to try and connect together. And then in addition, this is an optional, but I added in a starting shape that is shown in yellow. You don't need a starting shape. However, in this case, I actually did. So just as a little technical caveat here, in this instance, I actually didn't have a clear line of sight between the green brackets, and this would actually cause the generative design solver to fail because it can't work without a line of sight. So to work around that, you just provide a very simple starting shape, and that is enough to give the generative design solver a boost to start calculating from that scenario. So that's exactly what I did here. It's not a pretty looking shape by any means, it's very ugly, but I actually designed this using automated modeling. So the previous capability that I just showed you, I actually use that in here just to quickly generate a shape, just to give the generative design solver a starting point of where to calculate from. In addition, once you've defined the parameters like that, what you do is you define some of the objectives. So we just said, hey, we want to minimize mass. This is a safety factor. There are some other objectives you can define. So generative design has grown quite a bit since its first creation, and it's not just about minimizing mass. So there are some other targets we can try and hit with the solver. Now, additionally to that, we want to define what manufacturing options we have available to us. You could, of course, just tick unrestricted and it'll just give you the best possible result, but actually you might want to add some realism to it, and this is one of the big defining factors around generative design. It is more of a realistic solver. So here I've defined some additive options and also some milling, both 3-axis and 5-axis, and it's very good to get a range of options because obviously the 5-axis will probably be the better choice, but if the 3-axis is close enough, that's a cheaper manufacturing option. Let's just go with that one. So it's best to get a range of options and then for you to make a best decision at the end, which one is most optimum to go with based off cost and the design itself. In addition, I can chuck in a load of different materials. Now for this one, I just chose aluminium, but of course I could have stuck in up to 10 in total materials. I could have tried out a different metal, brass perhaps, maybe even look at plastics to see if a plastic could hold it. It's really good to get a range of materials. And basically what it would do is it will compare each material against each manufacturing technique and give you a result for each. So if you've got 10 materials, 10 different manufacturing techniques, you can expect 100 results. Some of those results won't be realistic, and so they'll just be not able to be made, so they'll be just struck off from the results. But ideally, if they could all be made, you'd be looking at potentially 100 results. And that'll come in looking a bit like this. You'll get this view of results. It can be a little overwhelming, but it's actually quite easy to look down into what's most effective. You get some recommended outcomes as well. And I like to use this graph here, which showcases, in this case, it's mass versus the safety factor up the side. So what I'm going to do here is just compare the 4 best results, the ones that are the lightest in weight, in mass, but still above that minimum safety factor of 2. So I can click all these designs, and we can actually go and do a comparison, which will just show the 4 of these designs next to each other. And this is a really good view just to see how each looks against each other. Now, the key to remember with this, it's never going to give you the 100% result. Okay, it's going to get you a lot of the way. It's going to give you some fantastic looking results, some great ideas as well, but there's still that need for a human to come in and make that final judgment call, just to consider all the other factors that might not be considered. So we can see here I've got 4 different results. I prefer this one at the top left, and if we click into it, we can actually see that is the unrestricted version. So there's no manufacturing technique applied to it. It's literally the best result. But that's okay, because I'm actually going to use that more as an inspiration piece. So rather than taking a realistic model away from this, I'm going to just use it for inspiration now. And this is another use case for generative design. It's not always about making a practical model. There's plenty of times you want to use it just for inspiration. And what I did here is I just exported that model out and I've just plugged it back in to the original camera gimbal here. And there it is in all its glory. And I thought this was a fantastic looking shape. It looks very exciting. Yes, it's not meeting all the manufacturing or meeting any manufacturing technique yet, so I might have to do some secondary exploration to see how close could we get this. Is it going to look close enough to the real thing? If we stick it on a 5-axis machine, there's a lot of other judgment decisions I can make. Plus as well, I just want to check it over to make sure it looks structurally sound as well for anything I might have not encountered. Quite often you get what's called a phenomenon called bird bones, where it will make a very thin structure, which, okay, that's part of the contributes to the whole design, but of course if we drop that, that's probably going to snap as well. So there's still a little bit of human intervention to be made at the end as well. But a fantastic automation and AI tool to generate results that you would never, more likely would never have thought of yourself. And we're seeing that get used more and more across the world. Now, next one, changing a different process here. We're looking at drawings. So we've actually introduced something called automated drawings. We still need 2D drawings in the world. They can be very time consuming. So we've taken a strategy of trying to reduce that time, and we did that with automated drawings. So I created 2 sets of drawings here. One is looking at just a simple part, and what I can do with that part, as you saw that just then, was what we call automated dimensions. So automated dimensions traditionally used to just copy over the sketches. So however you modeled it, it will just take that and put it on here. We never really sketch it the way we were going to dimension it in the drawing, so it was never useful. But this actually takes a good look at the part and gives you some options based on the style of dimension that you want. So you can see here we've got symmetric, you've got something called baseline, you've got chain dimensions, you've got symmetric with baseline dimensions. There's a few options here. Generally, baseline is my preferred, sometimes symmetric with baseline, and what that would do is just put all those dimensions on there automatically. Now again, don't think of this as a 100% solution. Think of it as it's done 90% of the work for you. That remaining 10% still needs that human intervention. It's on you just to clean it up, just to make sure it is true and accurate, and then of course add notes and any other details you want to this as well. So that was just for one part. I did create a second drawing in that time for the whole assembly, and this is how, I guess, convoluted it can get in a good way. Like, it's looked at that entire assembly and then analyzed, okay, how many drawing pages do I need? And it's created almost immediately 20 different pages for me. So one that looks at the overall assembly, and then it's broken it down into the parts, even sub-assemblies sometimes as well, and then applied auto dimensions onto it as well. So this is going to save our drafters a lot of time. That's the aim here. And again, even if it's not a 100% solution, even if it's just 80% of your time saved, that's a huge time saving. And that's time you can spend better doing other more important tasks. So automated drawing, very exciting, fairly new to Fusion as well. And if you haven't tested it already, certainly give it a go, because it is a real fantastic time saver. Now, the last one I want to show you is one of my favorites, actually. This is less of a tool inside Fusion. It's what we call API automation. So for those that don't know, APIs are the way you can interact with Fusion outside of Fusion, as it were. So I could write a script or code that can talk to the APIs in Fusion, and pretty much anything I can do in Fusion, I can write a script to automate that process, build something for me, change something for me. The possibilities are pretty much endless on this. So for this example, this was a real world example. We've got this Formlabs business card. We did a collaboration presentation with Formlabs, and we wanted to make a unique one of these for every guest we had in the audience. Now, rather than me making this 30 or 40 times individually, I wrote a script to automate this process. So we'll run through how that looks. So I activated my script. It's called name of customer. Here's a quick example of it. Now, I'm not a coder by any means, and so I just wrote this in Python, and I didn't really write it. I copied a lot of code off online. There's a lot of other people online as well willing to help and really helpful. So it's quite easy to get quite far in that very quickly. So we run that and it's asking me select the text. So we're going to put the text there on that sketch. It's then asking me, okay, pull off the list of names. So I'm just pulling off a list of names from that spreadsheet. Where do I want to save these files? And what it's going to do is export these 30 to 40 parts as STLs into a folder somewhere, because that's then we're going to stick them straight into the Formlabs 3D printer. That's the process they wanted. And here they are. It's done a batch of them there. Okay, and what I'm going to do is just quickly open them for you and just show you what they look like. So there we go, it's created an STL with a unique name on each. And here is the first 12 of them, each unique with their name. This would have taken me quite a long time to do manually, but with with a script that activates the APIs, it was able to do it within 30 seconds to a minute. And then I had all these parts ready to go in the 3D printer. Okay, so this is just a fairly simple example of what you can do with the API automation in Fusion. In essence, this allows you to create your own automation process within Fusion. And it is incredibly powerful. We're slowly starting to see more and more people create some fantastic automation scripts out there that can do all sorts of things. So certainly worth giving a try. If you've got a task that's quite repetitive, you want to save time, certainly give it a go. You'll be surprised at how quickly you can make a script that works. So with that, I will now hand over to Vipul. He's going to take you through the make side of things.
Hello everyone, I am Vipul Agrawal and I'm going to talk about what automations in AI we have in manufacturing workspace and make workspace. So we have figured out four segments which we are going to talk about today, and I'll show you some of the videos where you can see in action how these things work. So first thing that we talk about is CAM templates. Now, templates is a very good way of organizing your operations and storing it for reuse. So if you have the product which has same variants or types, then what you can do is you can store the processes that you follow for manufacturing them in form of templates. Now, these templates can be reused whenever you have the same kind of part or the same variant of part available again, needed again to manufacture it. This is a very effective way where you can also save it according to different materials, different parameters, and everything. We have also gone one step ahead in Fusion of storing the templates. Now, usually you store the templates in your PC, and when you want to share it with someone, you have to either mail it or send it to them by other means. Now, this breaks the link of if you change the templates or you have another process added into it. But what we have given inside Fusion is you now have Cloud CAM templates which can be stored. Now, the use of these Cloud CAM templates is once you store it in your cloud drive, whatever your colleagues, wherever you have a collaboration between your colleagues in your company, they all can use that template. So it's one person creating it and everybody else who can use it in their workspace. Now, if the templates are updated, that updated template also stays or goes to everyone without any need of sending it to them or giving a notification to them. It's by default shared with everyone. So here you can take the benefit of Cloud CAM templates and get your products manufactured as quick as possible. This is very useful because as you can see, there are multiple steps that gets involved. And instead of, selecting all the processes every time, you just go ahead and select or change whatever is necessary and you have the perfect toolpath ready. The next thing we would talk about is automated toolpath. So in Autodesk, we now believe that in CAM, there are a lot of automations that can be done, and the user inputs which used to be given at each step needs to be reduced. And that's why what we are trying to do is we are trying to reduce the inputs that needs to be given for a particular toolpath. So toolpaths like dibber, we know that whenever a machining happens, dibber needs to be used at the corners itself. And why not automate it? So the debug toolpath which we have will actually do all the or find all the corners of your toolpath and create a debug toolpath automatically on them instead of you going ahead and selecting all the corners one by one. Now this gives really good efficiency on doing your CAM programming because it reduces the time which you need to select all the features or all the corners around it. Second one is the rotary toolpath, where you can just select the start and end, and what it does is it will identify where are the pockets which needs to be machined and fourth axis pockets which needs to be machined, and it will create a very nice fourth axis toolpath. Now this also has another variant of for contouring. So if you want to finish the walls or if you want to finish the floors on it, it does the same thing but with your finishing operations. So these are some toolpaths which I have been showing here, but there are other toolpaths as well which you can explore if you are using Fusion on how it can be automated and how it reads from the CAD data to create the toolpaths automatically without you giving much of the inputs. The next is hole recognition. So in some of the parts which you have, there can be various types and numbers of holes which are there. It can be like in a huge number where the selection of each and every hole can become a really big task, or it can be of lot of variants as well, where you might not even recognize how the hole is made until you go ahead and manufacture it and then find it out. So what this hole recognition would do is whatever types of holes are there, you can just run the hole recognition to algorithm in it, and it will recognize what types of hole are there. And when you get to know exactly what types of holes are there, then what would happen is you can go ahead and select a template which you might have created or the process which you want, and within minutes, within seconds, it will create the complete drilling toolpath for you. Now, this works really well if you want to do it for multiple axis as well, and also it can identify on which axis which would be the, from which axis which would be the better hole to approach in that field. You can also select your own libraries, tool libraries in this. So just in case if you don't have the tool, it will give you an error message or a warning message that the tool is not available with you and you need to get the tool, buy the tool or get it appropriately inside the tool inside the CAM library or CAM tool library, which is there. Apart from this, this is a very powerful way of selecting all the holes and knowing how it is. A very fun fact that happened to me once is one of our customers gave us a product which he wanted to get to know about the hole recognition, and his designer didn't do a good job. What he did was to close one of the holes, patch one of the holes, he just added a surface on the top of it. So the hole was already there, but the top of it was closed. And what happened was when I ran the hole recognition toolpath, it actually identified that there is a hole inside of it and only the top has been patched up. So these are some kind of automations that is very useful to identify these things and get a more appropriate toolpath or cycle time right before even doing the actual machining. The next is configurations. If you know about configurations, this is a very famous tool in designing workspace, where if you have the same variant of the product with different diameter, sizes, color, or shape, what you can do is you can use the configuration, and instead of drawing and creating all the designs, you can just make the configurations quickly and it will adapt from them. Now, the same data, since Fusion is an integrated workspace, the same data can be used for manufacturing as well. And what we intend to do is, if you create a toolpath with just one configuration and one setting, what you can do is you can just update the configuration in the manufacturing workspace itself, and then refresh or regenerate the toolpaths, and it will generate the new toolpath for other configurations. And this is a very quick way if you have, again, the same type of parts, but with different sizes in it. Configurations have an extended use also. So you might have a fixed set of vices and a fixed set of fixtures in your shop floor, right? And you might be sometimes using a fixed set of a fixed size of raw material as well. What you can do, you can add all these things inside the configuration, and then whenever you get a new part to make, you can just select from the configuration that which is the best configuration that you need to put up on the machine. With this, you are quickly making the setup with you by using the configuration, and not every time placing the component, placing the vices and everything. Because in reality, if you see, there are only 4 to 5 sets of vices or 4 to 5 sets of fixtures that you have in a medium-sized shop floor that you reuse it every time. So why not make it standard and remove the programming or the software time by of placing that components each and every time. So this way, with the use of configurations, you can also automate the setup which is there. Now, apart from this, we have APIs that can also be used in manufacturing. Now I'm showing an example for doing a API for additive, but the same thing can be used for doing it in subtractive manufacturing as well. So you see what it is doing right now is it is firstly automating the input of STL files where there are several STL files and you want to import it and repair it. What this will do is it will import it, check if there are any problems in that STL files, and then automatically do the repairing if needed. Once the repairing is made, then what I can do is I can again go and use the API to do the programming of it. So you see there are multiple files which has been repaired and it has been renamed as repaired into it. So whatever manually you can do, actually you can automate those and create your own APIs also within it. And once this is done, I can ask the API again to create an SLS setup or an SLA setup for me. And what it will do right now is it will analyze what kind of setup it needs, what machines you have, and what is the best arrangement that it can do, and give you the complete setup which you can directly go and run in the machine. Now this is again something that needs to be created. We have a lot of sample APIs that you can use to automate a lot of things, and also as I mentioned, this is an example in additive, but in manufacturing, whatever types of manufacturing techniques are there, everything can be used to do that. We have an in uh, we have a functionality in fabrication also, which you can use to actually lay out the parts. That is called nesting, and I'm not covering it here because that is basically algorithm or a feature of nesting rather than an API of it. And finally, coming to the AI in manufacturing, there is a partnership with Cloud NC, which we have done, and they do several things in manufacturing. They have also automated a lot of things which can be used. The uh, the name which comes in is the company name is Cloud NC, and their app name is Cam Assist. And right now, there are two parts of that Cam Assist which I can see. The first one is you can create the fixtures. So whatever model you have, if you want to create soft jaws or fixtures which needs to be designed or which needs to hold the part at the bottom, that is something which can be again generated by just one command. You select what is the fixed face and where you want the fixture to fit from the sides, and it will create the fixture for you. And once that is done, you can go ahead and create the toolpaths also for this. Now there are several parameters and strategies and everything which can be checked also in this, so that what it does is it gives you a very good optimum toolpath and also makes sure that it's not heavily loaded on the machine. So it will give you a very nice toolpath which you can use, and also considering the tools where analysis, all the manufacturing factors which we do consider all the time during the manufacturing flow. So that will be all from my side, and thank you for joining this webinar.
Thank you very much for that, Vipul. Now, we've shown you what is available inside Fusion as of today. Some very fantastic features already that many of you can already take advantage of. Now let's pivot and take a look as to what is coming in the future. We've got three things to show you. These are what have been confirmed. We are, of course, working on a heck of a lot more, but this is what we can mention as of today. So coming to the future, we're going to start off fairly simple. It's simply enhanced automated drawings. So we already have automated drawings. This is great at creating different pages, placing down the different views, and then adding on automated drawing dimensions as well. This just takes it a step further. Those dimensions are going to get better. We're going to be able to add also other sorts of symbols and text around it as well. So we're going to try and get that process to as close as 100% of completion as possible. Again, it's a process that we all quite often have to make these drawings, but we don't want to spend time doing it. So that's what's going to be improved on in the coming year. Additionally, we're going to take that technology and start applying it into the design stage. So we're going to start seeing those recommendations in the sketch environment. So it's going to be recommendations around how to dimension and constrain the sketch as well. So again, something that's going to be a big time saver, but also a big help because sometimes it's not always easy as to how best to constrain these sketches we've made as well. So this is going to be applied to that, and we're going to see this flow more and more into the design space as well as we continue to build these tools. The third one is probably the most exciting one. We're going to launch our own AI assistant within Autodesk. Now, this is going to provide you with advice around your designs and around your manufacturing. We're going to launch it just in the manufacturing space to begin with, just to test it, just to try to get it working correct. And then it will go across the rest of Fusion eventually. But this will be, in effect, it's going to be like if there's a Marvel Iron Man reference, it's going to be like a Jarvis to your CAM processes. So you can ask this thing any questions, you can get recommendations on how to machine a hole, machine a feature, and it's going to give you its expert advice. It's going to be an expert assistant effectively available to everyone now. And this is going to accelerate a lot of the manufacturing processes, even for newcomers. It's going to teach them a lot of new tricks and tips as well as they go through. So a fantastic new addition coming to Fusion. And like I said, this is just going to start in the manufacturing space. The intention is we'll see this across the whole of Fusion as well. So you imagine having an AI chat bot that gives you real accurate advice and best tips as well throughout Fusion. That's just going to be a fantastic future in this industry and in this technology as well. So we're all very excited for that. So those are the three things coming that we can talk about. Of course, watch this space. This is a very hot topic. There's a lot of research being done in this area, and the next few years, 5 years, even more, it's going to be very exciting. So stay tuned, see what's coming out in the future. And with that, we'd like to thank you very much for attending today's AI and automation webinar. We build these webinars based around the questions and comments we get from all of our customers. So please continue to interact with us. Add us on LinkedIn. If there's any other questions or any other topics you'd like us to mention in a webinar, please reach out and let us know. Thanks again, and we'll see you in the next webinar.